Hi everyone, welcome to another episode of TrueML Talks. I am Nikunj Bajaj, co-founder and CEO at TrueFoundry, and today we have with us Harsh Verma, who is a senior staff software engineer who works in the intersection of machine learning and big data at Palo Alto Networks. Harsh, I welcome you to this episode, and I would love for you to introduce yourself more deeply about how you got into the world of machine learning, what brought you at Palo Alto Networks, and what sort of work you are doing at Palo Alto Networks as well. Would love to hear your journey a bit. Yeah.
Sure, sure. Thanks, Nikush. Thanks for the invite. Happy to be at TrueFoundry. Yeah, so just a little bit background. Yes, I work in Palo Alto Networks as senior staff software engineer and work in a mix of, I would say, big data, AI. Now, generative AI is all in the picture. So work in those domain of the latest tech stack. And the later problem we solve is in cybersecurity space, more over towards protecting and building the solution, which are more over towards uh, in the we should be able to recognize the patterns that are coming up from the different type of threads, protect them, build software in a secure way at a scalable manner. So that's the work I do, and intersection of all these, building those kind of products.
Lovely, lovely, lovely. Yeah. Would love to hear a bit more about your journey into how you got into machine learning. Like, what was your route to coming to Palo Alto Networks, Harsh? Like, why did you make a decision to join as a machine learning engineer in Palo Alto Networks? Would love to hear a bit as well. Yeah.
Sure, sure. I think the journey was quite drastic. I was doing software engineering when I was back in India, and I came to US to study my masters in computer science, which were concentrated towards AI, machine learning, and I was also a research assistant in my university where I was doing a lot of work on natural language processing, computer vision, and AI side. So that's where I think the interest speaks in, and the field is very rigorous, very demanding, and I think I also like to take your challenges, learn something on my own. So that's where I feel like this field is very growing, and it's always keep updating. So it's aligns with the intersection of what I also wanted. So that's how I got started during with the professor, and we were building some of the amazing products on machine learning, solving some real problems using machine learning and AI on that. So once I started with that, after my university, I joined Palo Alto Networks as a staff software engineer, where we were building the softwares which were kind of improving the policies or in a networking and all how to make software to recommend and provide more security based solutions.
Lovely. Awesome. Good that you found your way from working in software to working more in machine learning through your masters and stuff. So good to know that, Harsh. Would love to hear a little bit more deeply about, like, if you can help us orient, what does kind of your week to week at Palo Alto Networks as a machine learning engineer looks like. What are the type of problems that you're solving both in machine learning and generative AI, right, like classic machine learning and generative AI world as well, so that we would love to learn a bit more about your journey there. Yeah.
Sure, sure. I would classify, in the world of cybersecurity, I would classify the problems in multiple areas. One is the problem in detection itself. Like, how do you detect if some threat is coming or if there is some issue happening in the, traffic or data? Second is
Hmm.
the remediation step. Is like once you have detected that there is a problem that is happening in the network, how you can remediate it and provide user the solutions that will help them improve the security, right?
Right.
So it's fall into two category, I would say. One is detection part, one is remediation or solution part. So in the remediations, we have multiple products that we build on cybersecurity related, like how you can detect early, just looking at the traffic logs or looking at the network data that is flowing towards in the between the firewalls, and see how you can build those solutions which recognize AI solution which recognize these patterns in the logs, because human can't do it. It's like very massive petabytes of data logs, and it will be very crazy for a human to go and check each of the lines. So yeah, I mean, we built a solution where AI can go look at the past data from various customers and detect, like, okay, something happened like this when the traffic was flowing wrong way in X customer, and it could happen to Y also, so it could be a potential threat. So that's where the detection come in, and we classify those as a threats which could be a potential threat in networking. Now the second part is once you have detected any problem, or in, like, let's say urls, or you have detected problem, there are some threads in the firewall, and you want to, there's something going on wrong with the system or the software itself, and you want to provide solution which can really help them improve that security on the security front. So that's where we build another part of the solutions, where given these detections, we provide the solutions of improving the policies, that you can have in the network, or uh, you can have more analytics overview of how the traffic flowed in, what was the how many requests came in a day, and how many got classified as as failures, or what is the classification it is going on. So these kind of softwares that we build on both detection, remediations, classification side, which really helps to provide in general overall a secure software for the customer at the enterprise level, and they are able to feel more secure when they are doing all these transactions. Yeah.
Makes sense. Absolutely makes sense.
One of
So,
the live example I would love to give
yeah,
is, like, I think credit card theft and everything we have already seen. So that's also a practical example of how AI is being used in the practical world. And anytime you see some fraud is happening, AI sends you the message, okay, this is something that it has seen before, and it could also impact that.
makes sense. Absolutely makes sense. So, Harsh, I personally don't come from a cybersecurity background, and this field is relatively new to me. And I'm sure that for a lot of our viewers, they would also love to understand this, this space a bit more. So, if you can help us understand that, okay, you have two classes of problems: the detection of cybersecurity threats, and maybe you classify them on what type of threat it is, and then how do you remediate that, right? So, I understand that part. Now, what type of data are we talking about? What type of threats are we talking about? If you can help us illustrate this with an example, that okay, here's a kind of threat that we would detect, here's how we would solve it, and this is the initial data stream that we had seen basically, right? Like one model example of that would be helpful, and then from there we can get into the tech stack of how you build out a pipeline like this basically.
Sure, sure. Just to add on that, yeah, like, let's say you're using your system in the enterprise, right? And there would be multiple websites you will be opening in one day, multiple softwares that you will be using. So what we did in the background, our software does it does a analysis check of all these things that is happening, that whatever this you're using in the system, all the urls that you are going through, all the softwares that you're doing, we run them in the batch processing, real time processing. Like, if if there is whatever you have opened, if there is some issue in that, and the background system detects if there is something that the user opened which is not a potential, I would say, which could be a malware or a threat, then that has been came as action items from the software, and we pop up the user that, hey, this is whatever urls you are entering, maybe those could be or potential threats, right? So not to use them or block them. Then the second part also come is, like, strengthening the policies, where you want to make sure that user doesn't open Facebook, right? Or any traffic that is going to Facebook or any other application should be blocked. So the software is capable itself to define those policies at the global level, and so that we can block the traffic, and users should be safe to open, not to open all these softwares which are not in a valid zone.
I see. Okay. And so basically, this is primarily about on the browser when people are opening different websites. The Palo Alto Networks software would be able to detect if that website has any malware in it, basically, and kind of either alert the user or prevent the user from accessing that in the first place, basically.
So browser is one example. It could be any software that you're using also. So yeah.
I see. Okay, got it. And this data stream would look in the format of timestamp, and here's like a link that was open primarily. Is that, or the
Yeah, I
content of
mean,
the link
these are
as well?
networking, any networking logs. It could be anything any network related logs.
I see. Got it. Okay. I see. I see. Okay. Got it. And I'm assuming all of these models are obviously have to run in real time, right? Because as the traffic is coming in, you quickly want to keep your classification, detection mode on, basically, right?
Yeah, it depends on yeah. There's a mixture of batch and streaming that you do on that, based on the priority of the the work, the software demand. So there are some pipelines that we run on the batch level, some we do at the real time, based on the subscription license and all those user opt. Yeah.
Oh, interesting. What so like the example that you gave, flags, that okay, this is happening in real time. What would be an example of processing that is happening in the batch mode, Harsh?
Yeah, batch mode would be something, let's say, in the same example you can say how many were thread detected, whatever I used in my software, how many were could be the potential thread for the past 30 days. So 30 days data you can't
I see. Yeah,
stream
yeah, yeah, yeah,
stream,
yeah.
right? So there is a batch job which is running in the background, and going to the ML model which is classifying those and detecting that okay, these are the, in the past 30 days these could be the one.
Got it, got it, got it. I see. I see. Okay, understood. Makes sense. And are these models? And by the way, would you would you actually use generative AI in these models as well, or this is more classic machine learning model example that you just gave, basically?
Yeah, right now, I mean, as everybody is on the generative AI is a new thing. So yeah, everybody is trying that, and it's a mix of both LLMs also, and also the classic, basic modeling. Yeah.
Got it. I see. I see. I see. Understood. Got it. So, if you can help us understand, what type of tech stack that you are using to build a model like this, basically, right? How is your data? And of course, from I read a bit about you online, and clearly you have worked also a bunch on setting up these data pipelines, the big data pipeline engine as well. So, I'm pretty sure that you have familiarity with like that tech stack. Would love to understand how are you capturing your data, and what type of models are you building? What type of tech stack that you're using for those?
Sure, sure. I mean, it
And
comes to all, I would say, model building the model from the scratch and deploying to the production whole
yeah,
pipeline steps.
right,
So we have the first steps of like, basically data ingestion and part, and then data cleaning, data pre-processing,
right.
model training, model deployment, and then model serving. So these are the typical machine learning, how the pipelines in the machine learning model serves, going from starting to production.
Hmm.
So yeah, for the ingestion part, I mean, text in terms of tech stack, coding wise, we use Java, Python, and text. We also use like a Spark engine, which is which is helpful to process all these things, data flow, data proc, kind of a job, big heavy jobs, batch jobs, which process these raw data and convert them into the meaningful features. And using these feature engineering, then we save the data into, I would say, any cloud platform like AWS or Google, and there have multiple pipelines, which is even processing pipeline, which is looking to these raw datas and processing them, training them. Once the model is trained, then we deploy it as a service, and which can be served by any customer in the production.
I see. Okay, got it. So the data capture itself, it's a streaming data. So are you using something like a Storm Kafka pipeline here, or like a Flink or something? Like what's the engine that you're using there to capture the streaming data here?
Yeah, we can use any of those. That really depends on the team and the project's demand. In some of the projects we use Kafka streaming, in some of them we also use pub subs, to just trigger those event based things.
Understood. And you mentioned that you all use Spark. Do you use like managed version of Spark, which is with Databricks, or do you kind of run this by yourself?
It but no, I mean, we usually prefer to use the Google Cloud one, like the data proc cluster that you can bring in. It's a managed service by
Got
Google, or like a Google, yeah, Amazon EMR or something like that, right? Which can come up, and you can the batch processing can happen from there and goes to downstream.
Got it. I see. I see. And you mentioned that you all are using well, so the security here, like with Palo Alto Networks, if I understand this right, is offered through all the three cloud providers, right?
Yeah,
Or
it really depends on the project demand and the owners. Whatever platform they are more comfortable and want to use. Yeah.
okay, got it. And you mentioned that the once you have done the data processing and cleaning steps, the features that you have created for model training are logged into the respective cloud providers, so like AWS or GCP. Are you logging these features like in an S3 or GCS bucket, or where are you using a feature store kind of a thing, basically?
It's as I mentioned, it depends on the project and the team that you're using on the project demand. We use mix of G3, S3, GCS store, and also BigQuery to store all those feature and do analytics later on top of it. And feature store, some team also use feature store, vector store to store and already have them processed.
Got it. I see. I see. Understood. Understood. And the actual training of the model itself is happening in the cloud provider as you described, like the AWS GCP itself. And for the training and model management, are you all using like something like a SageMaker or a Vertex AI from the cloud providers?
Yeah, those some projects demand that, so we use it here.
I see. I see. I see. Okay. So, and like, any thoughts on that? Would love to hear, like, if you like, have you personally used these as well, Harsh? SageMaker, Vertex AI, etc.
Yeah, yeah. These things, I mean, like, I would say the in route of cloud provider, right? If you want to train and those kind of models, so what XAI gives you a very good platform to use it to build the pipeline, and then you can kind of have that in a DAG environment, where you can use each by steps, processing, training of the model, and then storing it to the GC store and all.
I see. Okay. So you have personally used Vertex AI and you seem to have a high opinion of it basically. And do you use Vertex AI both for like training and inferencing, or do you use it primarily for model training, Harsh?
It's used for mostly for the training, but it can be for the inference also. It can be used. It, as I mentioned, it really depends on the project demand. Some projects I've used it for both, and some projects mostly for training, so that the jobs can go, and then you can have them once you have the model ready, you can deploy it as a service on Kubernetes, or and then it can be served.
Got it, got it. This is where I would love to take a step back and kind of also understand a bit about like, how is your team structured, Harsh? So, for example, like, the reason I ask this question is that a lot of companies that we speak with, they have like, a notion of like an ML platform team that kind of exposes like, let's say some abstractions on top of Vertex AI, SageMaker, or any other platforms that they're using it under the hood. And then like, there are ML development teams that kind of builds and deploys these models, right? And in some cases, it's more of a unified model. Like, what's the team structure that you all have at Palo Alto Networks?
There, I can speak about the projects in the team I worked on. So different structure in different teams, but for us we have a specified role for data analytics, data scientist, data machine learning modeler, and also software engineer who will take these models to deploy it as a microservice where it can be served, and they who will be looking for more over on the scaling side and infrastructure side. And then we have SRE role also, who will be looking more over towards providing us the permission and leverage to build these platforms on the permission side, platform side, right? And then some engineers who are just focused on building the platform inference and batch processing part.
I see. I see. Understood. Got it. So it's, and like are all of these like, so you mentioned actually a bunch of roles, right? Data analytics and data science, ML engineers, software engineers, SRE, etc. Right. So the question is that are these all divided by, let's say, a problem that is being solved, or these are like different orgs which kind of support each other in the journey? Like, because that changes the dynamics of how the work is being done, right? Like sometimes all these roles are within a same team, and sometimes they're completely different teams, basically.
Yeah, these roles are dynamics of the project. If we feel that the project is big enough to be distributed among all these different area engineers, then it goes like this. Otherwise, if it's small, then certainly a bunch of engineers are doing in a startup mode, like everything.
I see. Um, Understood. Understood. Got it. And you never mentioned throughout this, like, as like, so there being like a central team that's building out, call it like a platform layer or a tooling layer to support the ML developers, basically. So like, a lot of times there's like a boundary between these are the things that an ML developer is working on. And then once the model is trained, that like, we hand it over to someone, and there's like almost like a handshake process of model handover, right? Wondering if any of that is something that you have personally seen. Again, I can imagine Palo Alto Networks being a very large enterprise. There will
Yeah,
be different
agreed. It's a
jobs in
it's a
different
large
teams.
organization, and I think every engineers have the freedom to opt like what they work on and what areas they feel more comfortable with. So some engineers, they have intersection of all these different areas which we mentioned: data analytics, data engineering, model deployment, SRE. So they like to do everything on their own, and they're free to do that. Otherwise, some like to say that these are my area of expertise. I would like to only train the model, work on more these areas, and then hand it over to other folks, right? So for the deployment and all. So it really depends on what the team is demand is, project demand is, and how each of them wants to work.
So like, thanks a lot, Harsh, for like, guiding thus far. You have, of course, talked about how you set up the data pipelines, how you set up the feature engineering pipelines, and the model training as well, right? Like that you're doing this model training primarily within the cloud providers themselves. Now, when we get into the model serving aspects of it, right? What are some different ways in which you have seen that the ML engineers are hosting these models? And this could be either through tooling platforms that have been provided by the internal teams, or by, by doing it themselves on top of the cloud providers, right? What are the different ways that you have seen, and any interesting challenges that you ran into when you were deploying these models in different ways, basically?
Sure, sure. I think yeah, I can give one example where in the recent project I was working, where the model is had the different versions of versions associated with that, and we wanted to take sure that stable model always goes to the reproduction. So there was one inference pipeline that we built with some test data, which is hitting these versions of model at a in a sporadic manner, scheduled manner, and we whatever accuracy we are getting based on data set, that's the model with the highest one gets picks up and automatically get deployed to the production. So for that one, you could use some tech stack like Argo CD and all, where that we have the latest image being built based on the accuracy parameter, and once the top model image is ready, then that get automatically using the continuous deployment gets deployed to the prod, so that anytime the customer is asking for any inference, it always have the most stable and most latest version of the model. Another way I've seen people, or I've also used it, like taking the model itself to be part of the service inside a service, and you can say a Kubernetes container, right? Or taking that as a library to build the model to be part of the library, and then have a Kubernetes container where it can be deployed easily in a HPA scaling mode, auto scaling mode, and any inference. This helps to auto scale models inference also. If there are 10,000 requests being served by one pod, in the HPU, it would be auto scaling itself based on once the CPU memory and those parameters are hit, right? Based on what you have said. So this is also another way. Third way is also using the Vertex AI. Vertex AI also has a serving layer where once you have deployed the model, build the model, you can deploy it in the Vertex AI serving layer, and it automatically gives you an HTTP endpoint which can be used to get the inference and serve the data from there.
I see. Got it. So this makes sense, Harsh. Like, the first approach that you mentioned, where, you had worked in a setting where you had different versions of the model, and you are saying that in real time you were basically figuring out which version of the model is performing best on the data, and you were automatically switching across the versions of the model.
Yeah,
So this one I would love to dive a little bit deeper into and understand a bit more, because, like, what is a setting where you were able to figure out the ground truth and evaluate the predictions, and at what frequency would you switch the models, basically? So would love to understand this a bit more.
sure.
And
We had, like, already, I would say that the train data set and the test data set split, and every time a new production data is coming, the pipeline keep splitting them in the randomly, and the one pipeline is going to train their model, other pipeline is for the test inference, where it hits these model in a sporadic manner, in a batch nightly job, right? Or a daily scheduled job, where different versions is being hit in the and get the inference. We collect all those stats from all of this, measure what is the recall accuracy among all of them, and whichever is we feel is performing better, it's being deployed to the production. So it could be like, today I'm working with model A, and then next time it will be model B and C.
I see. Okay, so this is not happening in real time. The training and model selection is happening, you're saying, offline as a nightly job, basically.
Yes, yes.
I see. Okay, got it. And, like, then through the day, a single model itself is getting deployed, basically.
Yes, yes. So it's a bad job which runs and determines the accuracy and inference, and based on those numbers, we take a decision to move it.
Got it. I see. It's very interesting, and so a lot of times, like, people talk about how, once you build a model, like, the best. And by the way, here are we talking about the classic machine learning model, assuming that you're trying different hyperparameters and training a bunch
Yes,
of models at the same time, right?
yeah, yeah. These are the classic ones.
Right. So in practical sense, we have seen a lot of times that, like model configuration for a data set distribution being constant, right? Kind of turns out to be like, let's say random forest with a certain configuration turns out to be the better one. And let's say if it's working best, it keeps on working best, right? So in this example, it seems like every day you were getting to a point where different variations of the model were working better. Do you have like, any, like, maybe any thought process on what scenario do you see completely different configurations of model would actually work out better in different cases, basically, right? Day to day, the model being changing. That's the thing that I would love to
So
understand.
that's why it really depends on what's the underlying algorithm you have used. XGBoost is one example. If you have k-means and other classifier also, that's a separate one. One of the example I would say is like, if you're using latest the LLMs and everything also, there is different versions of prompt that we want to try and see how the response is coming from LLM, right? The generated response. So that is one example where we are trying 10 different prompts, seeing how the data is coming from the nightly, the latest ones, how the inference are coming, and the best inference one gets updated to the prod. So it really depends on hyper parameter tuning or the metric tuning. It really prompt tuning. It really depends on what is the underlying algorithm. Based on that, these selections, or I would say these nightly jobs are made.
Got it. Makes sense. Cool. Awesome. Thank you so much, Harsh, for talking through this. Maybe like just steering the conversation a bit towards the generative AI. You mentioned that like as the world is moving to generative AI, you all are also using a bunch of generative AI as well, right? So do you all like primarily index on one of the closed source models, Harsh, or like have you done a lot of experiments with open source models? If yes, any learnings from there that you can share, basically, like on how you made different choices? What were the parameters that you'll consider when making choices with generative AI itself?
Yeah, I mean, I would say you can use any open source LLM, also Llama 2 and all of us. The problem with them is like it underlying keep changing and everything, and you have to do a lot of fine tuning for your use case and all. The better word would be to also to use some, the enterprise level open AI one, or the Gemini that we have provided by the Google. uh, you can base your projects on those underlying models that is being provided, and try different, for the fine tuning, try different techniques, like I would say prompt engineering, where different prompts can be tried on that. And along with that, build your own, I would say rack pipeline, and in which you can provide your proprietary or data to the prompt, or to the model, to get more use your data specific, or I would say your domain specific response from that, and fine tune the model. Yeah. So the challenges with using open source is always like, if something changes, then it's hard to rely on all. With enterprise level, if you are building the software at this scale, at enterprise level, it's better to be with the, those models which are very reliable, and you have the support also with that. If something went wrong, you can come up and say, okay, this version is not better, and when we can expect the next one, and those things.
Got it. I see. What do you mean by something changed in an open source model? Like what type of changes are you referring to here, Harsh?
I mean, it's depend on, it has tuned on a lot of data, a lot of parameters and all, and it's hard to fine tune that for your own purpose specifically. So when you are using an enterprise level, you have based on the request and the demand of the project, you can talk with the engineers and see like, okay, these are the ones, the changes we are pitching in, and so if we can fine tune and build a pipeline on top of it. Yeah.
Got it. Okay. Understood. Nice. Um, got it. Have you all tried like fine tuning any of these models by the way so far? Any learnings there, Harsh?
Yeah, mostly I used it on the rack, building a rack pipeline on top of it.
Okay.
So it's like you give the prompt, you do something on the prompt engineering, fine tune that, and also provide your data source that we have at the, at the company level, a specific domain to the model, and the combination of that, chunking the data whatever you want, so that whatever the user is asking on a natural language processing, it gets out, the model is able to infer and give you the right response based on that.
Got it. Okay. Understood. Cool. And one other question, like, you talked about, like, the benefits of using the enterprise grade, like, closed source LLMs. We have heard like one of the problems with that being the latency or cost issue when you're operating these models at scale, right? Especially if you're using them in real time, then the latency could be a concern. Have you all seen any of the applications that you're using these models into being latency sensitive, and how have you circumvented that problem basically?
So there are different versions of, small, medium, large size versions of, if you say Gemini is also, it has Gemini Pro, Gemini Ultra, those
Hmm.
things. So it depends on what kind of project model you are using and project demand. So if you're facing latency issues and those, then maybe upgrade to the latest one, or a bigger version from these cloud providers. That really helps to solve the problem. Yeah.
Got it. Okay. And any ideas on the rate limits and stuff, because that's the other thing that we run into quite a bit when people are using the
Yes,
cloud.
yes.
Yeah.
So that's the first thing I think we evaluate when we are trying to use these any of the cloud providers ones, is to see how many requests we are making per second, and where the point of hallucination is breaking, or how much it can cater. So that's the first exercise we do whenever we try to import any cloud-based LLM, or any open source one, to see. And then if we are hitting the issue, then we know, like, from there we have to scale it up, and go to the new version, later upgraded version.
I see. I see. I see. Got it. And anything around the gateway layer, especially given that you all use multiple clouds, and you could, like, for some applications, you could be using a Gemini, and for some applications, you could be using an Anthropic or a Azure GPT or whatever, right? So, like, do you have, like, do you all use a gateway layer to route the request across these models, or like these are just more individual API requests right now?
So I mean, it depends on the project. So one of the project I work on, it where it was just using the Gemini or any specific model, then it is a direct combination from API to just use that. In 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 one of the project, we used like multiple LLMs. From one response of the LLM is going to another one, and then giving you the cumulative response, right? So there it's like another one page is using the AWS one is using the GCP one. So there it's like a more of a API layer, and internally it gets called to each of them and give you the final response.
Got it. Okay. Understood. And one last question on this topic, Harsh. Like, have you all built, have you all tried or built any guardrails for, building out these generative AI applications as well?
Yeah, I mean, see,
Or have
prompt.
you tried any frameworks maybe for guardrails? Yeah.
Yes, yes. Just like we earlier used to have database as a service, and there was SQL injection happening and everything. So just like we have LLM, there's like a prompt injections that people do, which really leads to giving all your data to different to the to the hackers. One of the example I see was like people were using in the LinkedIn, where one of the scrape job was scrapping the LinkedIn profiles of the user, and there was a prompt prediction to scrap the user's detail and also send it to the specific email. So this way, I mean, like, prompt injection is really making LLM to hallucinate and to do some actions which it should not be, and get the data to the hackers or user or different and malware things.
Got it. And to solve for these problems, have you all tried any guardrails frameworks or something? There's a few open source frameworks and some closed source ones as well.
I haven't tried any of the open source one, but we do like the custom ones, custom guardrails for sure. Wherever we are doing any entity from these LLMs prompts and all, where we already see like whatever is coming from the user in the natural language, we first do this entity recognition validations of whether it is not any doesn't have anything which could inject in the model as a prompt, or append that to give those unwanted response. So we all those custom validations, and if any request is there, then we reject that.
Got it. Sounds good. Amazing. Maybe one last question before we part off for today, Harsh. Looking back at your last few years of experience at Palo Alto Networks, any particular time or project that you have worked on that is most rewarding in terms of kind of some of the impact of machine learning being made, or just the grandeur or the scale of the project that you have worked on, basically, or any complexity, any of those metrics that you care about, I guess. Would love to hear any stories from your life. Yeah.
Yeah, I mean, I would say the domain itself is very interesting. It's very demanding and very research oriented. Every day new things, LLM came up. Now people are doing prompt injection and all those things, so you need to also build some softwares which can safeguard these things. And every time upgrade, basically be smarter than the what the user is typing, so that you can safeguard all those things. The reward, I would say, is the actual impact on the companies and customers, because you are making sure that their data privacy, data validations, and all those policies that you have is made sure, and then the software that you're using is more secure, and people feel safe when they're using these tools and technologies. So I think that's the reward. Challenge, yes, obviously scale is one of the most important challenge. And when you are looking at these petabytes of data coming in, and you need to build some solutions which traverse through all those data, give you recognize some meaningful patterns quickly on that, and then respond back. So challenge and latency, scale is these things.
Makes sense. Awesome. Thank you so much, Harsh, for taking the time and speaking with us today on this episode. Really, really appreciate you doing this.
Yeah, thank you. Yeah.
Thank you so much, Harsh. Yeah.
Bye.